Hello everyone, I am back today with more SAT Math. We have one episode before and now I am going to do another. Today we have 3 questions and I am going to go through them one by one. So first thing, which of the following is equivalent to the complex fraction above? Here, this complex fraction. And we have A, B, C, and D. So the first thing to do with these fractions, if they are stacked on one another, if you see this is a fraction and the denominator is also a fraction, it is best to write it in a linear way, like a plus b over b divided by a minus b over ab. So basically we are giving ourselves some room to see it, not write it in this stacked way where you cannot solve it at all. You may solve it, but it's gonna be likely to be wrong and it's very hard to do, so why not? So when you convert it to the linear form, you get this in a line, and you remember that division is the inverse multiplication, which means you flip AB up and A minus B down, and we get this. And when you multiplying, you give them the brackets. It is A plus B times AB, and in the denominator it's B times A minus B. So we are now going to reduce the terms. You see, you can only reduce the terms that are multiplied, not the terms that are added or subtracted. You see, you cannot receive plus b or minus b, but you can reduce a plus b or a minus b because it is a multiplied term. So we need to see which term is common here. It is b. B is a multiplied term, and the b here is also a multiplied term. And so that gives us the final equation is a plus b times a, and in the denominator is a minus b. I'm gonna enlarge this, give it larger size. Here, you see, convert it to the linear way of writing, divide it, give it brackets, reduce the common terms, and we get, it is basically C, but I will give you the correct answer because I will explain here. So A, you need to open up the brackets. It is currently in brackets, right? But the answer has no brackets, which means that you have to multiply them out. So how do you do that? You multiply every term in the brackets with the term outside the bracket. A times A, here I'm gonna write it down. So A times A is a to the power of 2, and let me write that in superscript. It's a to the power of 2 plus A times B. See, the bracket is gone and the denominator is the same. So we get C as the correct answer. Yeah, I'm gonna mark it here. See, C is the correct answer here. Second question. Function of x is a times x to the second power plus 6. For the function f defined above, a is a constant and function x equals to 3 results in the function having a value of 24. What is the value of f minus 3? So this is the function and they have given us one value of the function, and what we need to do is to substitute the x here into this original function. So we are first going to write it down. F equals a times x to the power of 2 and plus 6. And when we substitute it with 3, because a is constant, it does not change, we substitute it and then we get f. Oh, I'm gonna insert an equation, fx, and here we get f of 3 equals a times 3 times 3, because it's 3 to the power of 2 plus 6, which equals 24. and we need to solve for a here. Alright, so equals 3 times 3 is 9, so 9a plus 6. 9a plus 6 equals 24, which basically results in a equals 24 subtracted 6, 18 divided by so it's 18 divided by 9 equals 2, so a is 2. We get the resulting function. The resulting function is a substituted 2 in, and this is fx. So now we substitute the value that the examiner is asking for, and in this case it is minus 3. Alright, I'm gonna substitute it in right now. Minus 3, and x becomes minus 3, and we get the value of 2 times 9 plus 6 equals 24, same as above. Okay, or if you see a very quick way of doing, just for this function, you see x is to the second power, a is the constant, 6 is also a constant, so everything in the function is a constant except for x. But any number, regardless of them being positive or negative, to the power of 2 is always a positive number, right? So essentially function 3 equals to f minus 3, and then you can immediately pick a as the correct answer. Now it's all in bold. I'm gonna here, a is the correct answer. You can do it the long way, or you can see the similarity and then just pick the right answer right away. Okay. Third question. In a triangle, in the triangle above, a equals angle A equals 3x plus 20, and b equals x minus 10. If cosine of a is equal to sine of b, what is the value of x? Now, figure not drawn to scale, so you cannot assume that this is a right triangle. Basically, they do not say that the triangle is correct, therefore you can only visualize, not take the angles for granted. But if you see here, cosine of a equals sine of b, what triangle, what kind of triangle does that sound to you? It's a right triangle. In a right triangle, the cosine of a equals to sine of b, the alternating angles. Okay, so let's call it ABC is a right triangle because cos A equals sine B. Therefore, A plus B equals 90 because one angle is already 90 and the sum of all angles in a triangle is 180. Okay, 90 degrees, and this equates to 3x plus 20 plus x minus 10 equals 90. So that's 4x plus 10 equals 90, and that makes 4x 80, and then x equals 20, so x is 20 degrees. So this is a very short math, but I think the shorter time is attributed to me more proficient in typing these kind of equations. The questions are maybe easier to explain, or the questions are just easier in general. But in the SAT you get your fair share of easy questions or hard questions, and we do not want to get the hard questions. It is important to know the easy questions first, because the hard ones are usually based on these questions, just a higher level of application. So by understanding the theorems, the rules, the operations attached to these kind of easy point-giving questions, you familiarize yourself with the test and you will do better as a result. I hope everyone a good day and thanks for watching.